Hi Chinmay, good to see you here. So how are you doing? All right. So guys, first of all, let me welcome you all to the Unacademy JEE English. All right. So this is a brand new channel by Unacademy, and on this channel, everything is being taught to you completely in English. So this is a series that I host for class 11 students, and this is lecture number 6 of Newton's laws of motion. And today we'll be talking about constraint relations. We started the discussion in the last class. We'll continue with that, and we will discuss some problems about with constraint relations, and then we'll take a look at variety of problems and how to go about solving those. All right. So before we move ahead, let me introduce myself one more time for those of you who still don't know me. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for the past almost 8 years, I have been teaching physics for IIT JEE. I myself was JEE rank 447 and All India rank 192 in the two stages of JEE that I took. All right, and I also qualified the NTSC stage 2, and I was in the top 1% in the NSEP exam, which is the first stage of National Physics Olympiad. Good evening, Harish. And hello, Subhanesh. How are you? So I've already coached many students to top ranks in ITJ in the offline setups. All right, this is my first online venture. So I hope to continue doing well with you guys, coaching you guys to success here as well. So first of all, let me tell you, moving forward, what are the benefits of the Unacademy subscription? So your Unacademy subscription gives you the opportunity to attend live classes. You get to interact with your educators, and then of course you have live polls and leaderboards, which keep your classrooms highly interactive. All right. Next, of course, you have test series and analysis, which is very important when you're preparing for such a competitive exam. Hi Pawan, how are you? And of course you have live doubt clearing sessions. So again, very important feature, because I know doubts give students a lot of trouble. So as a compulsory feature of all the Unacademy courses, every fourth session has to be a live doubt clearing session. So with the Unacademy Plus courses, your doubts are always taken care of. Next, besides these wonderful features, Unacademy also gives you the opportunity to access India's best educators on a single platform. All right, so Unacademy has gotten hold of a lot of top educators from all across India, and you have the opportunity to study from any of the one of them now. Hi, B Kaushik. So next, how do you get this subscription? Very easy. First, you need to install the app. Once you have done that, go to the plus section of your app, select your goal as IITJ, and click on that Get Subscription button. All right. Now, please remember that prices are going to get hiked from 10 September onwards. So hurry up and get your subscriptions if you haven't gotten them already, and use this code RD Live to get your subscriptions. All right. So this is what the old prices are currently. Currently, the 1 year and the 2 year subscriptions are at 30 and 36,000. If you use this code RD Live, then you get a 10% off, and the cost of these subscriptions becomes 27,000 and 32,400. I think for all you class 11 guys, this subscription is a must. You should know that this is coming to about 1,300 a month, which is less than 50 rupees a day. All right, less than 50 rupees a day. So obviously you should be going ahead and getting your subscriptions if you haven't got them, because at these prices, these subscriptions are a must have. All right, this is what the prices will look like from 10th September onwards. So from 10th onwards, or from tomorrow onwards, this is what the subscriptions are going to cost you. So they are still very competitive. The pricing are still very competitive. Again, this is the price that you have to pay if you use the code RD Live. Otherwise, you pay this. All right, but still, so one more day to go. Save yourself the money and get a subscription at these prices as soon as possible. All right, don't forget to use this code RD Live when getting your subscription. All right, so this will give you a 10% off. This is my code, and this is my gift from you for you guys. All right, so 10% off. Doesn't matter whether you're paying it on the new prices or the old ones. All right. So do remember to use this. Please remember, last 1 day left to get your subscriptions at these prices. Otherwise, the prices are gonna go up from tomorrow onwards. So get them today. Get them today only. All right. Okay, for those of you who are following us on the JEE English channel, can connect with us on the Telegram app using the link shown above, so that you are getting all the notifications of all the lectures and sessions which are being held here on this channel. All right. So why don't we get started with the topic of the day, which is Newton's laws. All right. So today, as I said, we'll be talking about constraint relationships, and then we'll be discussing a lot of problems. All right. So today's session would revolve a lot around problem solving strategies. All right. So remember last time we were talking about string constraints. We discussed about string constraints. All right. So here is a problem to warm you up. Let's see how much do you remember from that discussion. So in this situation, you have been told that the speed of block A is 5 downwards, that of block B is 2 meters per second downwards. You have to find the speed of block C. Hi Chinmay. So do you remember? Yes, last lecture. If you remember the last lecture, why don't you give this a try? Let's see how many of you can give me an answer for this. What will be the speed of block C? Go ahead, give this a try. All right. So try this. Let's see. Let's see if you have an answer for me. Let everybody give this question a try. All right. All right, people. I'm waiting for your answers. Okay. Let's see some answers soon. What happened to Pavan, Sukhvanesh, Harish? Where are you guys? Give me some answers quick. All right. So Pavan says 4. Okay. No, Pavan. No, 4 is not the right answer. Okay. Sorry about that. 4 is not the right answer. So you haven't been practicing like I told you to. All right. You should really listen to me and you should pay attention to my lectures and practice after the lecture. Okay, so Sukhvanesh also says 4, which is strange. No, guys, 4 is not the correct answer. 4 is not the correct answer. All right. So give it another try. Give it another try. Or let's see if Harish can get this right. Is Harish still here? Are you trying? Okay, how come you guys are giving me the answer as 4? I don't understand. Okay, let's see, let's see. So this is a standard string constraint problem. All right. What did I tell you about string constraint problems? How do we solve them? We solve them using virtual work methods. Remember? All right. So let's start assuming the tensions in different strings. So let's assume the tension here is T. All right. Next, obviously the tension here would also be T. The tension here would also be T. Tension here would also be T. Tension here would also be T. So all these strings, because this is one single string, so everywhere the tension would be T, right? Now, what about the tension here? I told you when pulleys are ideal, so the net force has to be 0, so the tension here would be 2T. Similarly, tension here would also be 2T. All right. Now, let's imagine, yes, 14 is the correct answer, Pawan. So, if this goes down by XA and this goes down by XB, and let's imagine that this goes up by XC. Now, what will be the work done by the tension forces on all the blocks? So, tension would do negative work on this, and positive work on this. All right. What are the works? Let's see. Yes, Pawan, this is the correct answer. So, minus 2t into 5 minus 2t into 2. All right. Okay, so let's just stick to XA XB right now. We will differentiate that later. So minus 2txa minus 2txb plus txc, that would be 0, which tells you that xc would be equal to 2xa plus 2xb. Now if you differentiate this, you will get the relation between the velocities. So v of c would be 2 times v of a plus v of b. So that gives me the answer as 14 meter per second. Alright, this was a simple problem. You guys should be paying more attention and practicing a bit more. Alright, just do that and you'll be fine. Okay, if this is clear to all, should we move on to the next question then? Should we move on to the next question? As I said, today I wanted to discuss all the variety of questions that you have with Newton's laws. I wanted to discuss a lot of variety. So let's see, let's get you a hang of things, how to crack problems of Newton's laws. So here is another problem now. Now this is a slight variation from all the problems that we have discussed so far. This is slightly different. All right. So the system is released from rest. You have to find the accelerations of all the blocks and tensions in the strings. All right. So why don't you guys give this a try? Why don't you guys give this a try? Let's see you try this. Okay. So this is yet another problem. Let's see if you can try this. Okay. All right, try this quickly, guys. Let me know in the chat that you are trying by writing trying. It's always good for me to know who all are trying the problems. Okay. All right. Hurry up with this. A1 equals 40. Okay. No. No Pawan. All right. Chinmay is trying. So Pawan, here you can't be taking all three as one system. I know what you 40 in any case. I don't know. 40 it can never be 40 by the way. In any case, it cannot be greater than G, right? How can it be greater than G? So try again. Try again. And also let me tell you that in this case you cannot take the thing as one system. Why? Because different masses here are moving with different accelerations. So you should remember when I told you that we can consider multiple masses into one single system as long as they are moving with the same acceleration. All right. Okay, maybe I don't know. I don't think so. But let's see. Let's see some more answers. All right, I don't remember the answer for this right now. I'll just have to solve it and see. All right. Hmm. Okay. So let's wait for some more answers. So acceleration of 1 kg, I hope you're saying is 4. Acceleration of 2 kg, you're saying is 5. Okay. And acceleration of 3 is 5 and 2. Okay. That cannot be correct. That cannot be correct, by the way. I can tell you straight away that. Okay. I can straight away tell you that those answers cannot be correct. See, I'll tell you one thing. If suppose this pulley is moving down with acceleration A pulley, all right. If I go into the reference frame of the pulley, so from the reference frame of the pulley, you realize now the pulley has stopped. All right. In the reference frame of the pulley will not move. So let's say this is moving up by some A2, A3, and this is going down by some A2 in the reference frame of the pulley. All right. So both of them would be going down with the same accelerations, by the way. In the reference frame of the pulley, if this goes up by A, all right. So let's this will go down by A, by the way. So if this goes down by A, then in this reference frame, the other guy would go up by A. All right. So what will be the accelerations of both the blocks in the ground frame? In the ground frame, you add the acceleration of the pulley. I hope you can see that. So these are the accelerations A equals acceleration of 3 and 2 in the reference frame of the pulley. I hope you remember from your relative motion that acceleration of A with respect to P would be acceleration of A minus acceleration of P, right? So acceleration of A would be equal to acceleration of A with respect to pulley plus AP. So you have to add the AP vector. Alright, I hope you remember this from relative motion. So what will be the ground frame accelerations of 3 kg? Ground frame acceleration of 3 kg would become downwards A plus AP, and the ground frame acceleration of 2 would become downward AP minus A. Alright. Now you will notice one thing. That the acceleration of the pulley is the average of both these. So remember that whenever you have a situation like this, whenever there is a pulley from which two masses are hanging, the acceleration of pulley. So let's call this uh, let's call this A, let's call this B, and let's call this C. So acceleration of pulley you will notice would be acceleration of A plus acceleration of B over 2. Alright, from these values, you substitute these values, you will realize that. Okay, this is acceleration of B, this is acceleration of A. So in ground frame, the pulley acceleration is always the average of these two accelerations. Alright, remember this. So that is why your answer cannot be correct. Okay, so no, this is the JEE English channel. This is I teach physics here. Alright. Okay. So now let's see how do you solve this. So okay, so one, what you can do is you can write your constant equations like normally, or you could have solved it in the reference frame of the pulley, but we are not going to do that right now. All right, why? Because we haven't studied pseudo forces yet. So let's just solve this using the regular methods that we have studied so far. All right, so let's see how to solve this. Let's see how to solve this. All right. So again, let's just stick to those names. So let's call this A, let's call this B, and let us call this C. Now let's start marking the tensions. Okay, so let's assume the tension here is T, the tension here is T, the tension here would become 2T, and the tension here would become 2T. Alright, now let's just write the equations for all the individual masses. So here remember in this case I cannot consider all three masses into one system. Why? Because they will be moving with different accelerations. Okay, I hope you realize that in the last what I just showed you, the acceleration of B and A are definitely different. Okay, so obviously the three will not have the same acceleration, so that is why I cannot consider them into one system. So now how do I solve this? I write the equations for individual masses. Alright, so that is what I do. Let's see. So first for A, what can I say for A? For A I can say, assuming that A is going up. Okay, so T minus 2G equals to A of A. Alright, so I'm assuming that this is going up by A of A, this is going down by A of B, and let's assume this is going up by A of C. So these are the directions that I'm assuming. Okay, I can assume any direction, by the way. Even if I have assumed the wrong direction, I will get a negative answer. Negative answer would mean the acceleration is in the opposite direction of what I assumed. Okay, so now let's see how to solve this. So similarly, for B, what can I say? For B, I can say that 3G minus T should be equal to 3AB. Alright, so this is my equation number 1. This becomes my equation number 2. Similarly, for C, I can write T minus G equals A of C. That's my equation number 3. So I have 3 equations, but I have 4 unknowns. T, AA, AB, AC. Alright, so what do I do next? Next, I look for the constraint equation. Hi Sumant, how are you? Next, I will look for the constraint equation. Alright, so where do I get the constraint equation from? So remember our virtual work method. Alright, hello Sumant, how are you? So how do I use the constraint equation? I will remember that. Let's find the work done. Alright, so work done on A would be T times XA in the positive side. So I can say that T times XA, that would be the work done on A by tension, plus how about B? On B the tension works negative. Why? Because the tension is acting up and I've assumed B to be going down. So it will be minus times T times X of B. For C again, it will be positive. Why? Because the tension is acting up. Okay, so yes, I need to correct this. I just saw. The tension acting on C is 2T. So the work on this would be plus 2T times XC, and this will be equal to 0. So if this is equal to 0, then third equation that I'm getting is that A of A plus 2A of C equals A of B. That is my fourth equation. Now that I have all four equations, now let's try and find these values. Okay. So now what do I do? Okay, so first of all, I can add equation 1 and 2. So let's do that. Okay, and okay. So let's just start eliminating things. So let's put the value of t from any one of the equations. So from 1, let's start solving this. From equation number 1, I can say t is equal to 2 times AA plus G. Alright. Now let's substitute this in 2. So if I substitute this in 2, what am I getting? I am getting, put this in equation 2. And let's see what that gives us. That'll give us that 3G minus this equals 3AB. Okay. So let's just write that 3G minus 2A of A plus G equals 3AB. Alright. So this becomes G equals 3AB plus 2AA. Alright. So this is what I'm getting. Now for the last equation from here, I need to again substitute the value of t here also. So if I substitute the value of t here also, let's see what I'm getting then. Then I'm getting 2 times 2 times acceleration of A plus G. Okay, so I'm putting this value of t here also. That is what I'm doing. So I will get minus G would be equal to A of C. Alright, so let's see. What am I getting? I am getting 4AA plus 3G equals AC. Alright. So I've gotten this equation, Alright, now I can use this equation and substitute the value of these differently. So okay, let's put the value of AB as this here. So if I put the value of AB as this here, what do I get? In this one, I will get G. Okay, so why don't I solve this rest of the thing on the other side of the page? So let's solve it further here. So I had this equation, right? In this equation, let's substitute the value of AB from here. So what I get is G equals 3 times AA plus 2AC, alright, plus 2AA. Alright. And now for AC, I will substitute this value. So then I am getting this equals 3AA and plus 2AA, that is 5AA. 5AA plus 6 times AC becomes 4AA plus 3G. All right. So now I am getting G equals, this would be 24, 24 plus 5, 29, 29 AA plus 18 G, or AA equals minus 17 by 29 G. That is the answer that I am getting, Pavan. All right. So this is a longest solution because this is a complex problem. That is what you get. Okay. Now you can find the rest of the expressions also. All right. So of course, Pavan, your answers were not correct. This is the right answer. Okay. The expression of A is coming out to be minus, by the way. Minus means I had assumed it is going up, it will actually be going down. Alright. With this expression. And now once I have this, I can start substituting the values and I can find the other expressions also. Okay. I substitute this value here, I will find A of C. I substitute this value here, I will find A of B also. Alright. So this is how you will solve this problem. Please note. It is not that easy. It is a very complicated problem. And this is how you will solve it. Alright, so let me know if you figure out how we are approaching this. So first we are writing the equations for all the individual masses. So that is how I get three equations. And then I write a constraint equation. So that is how I get four equations. And I have four unknowns. Expression of A, expression of B, expression of C, and the tension. So now I can solve all these four equations and find all my four unknowns. Okay. So this is going to be slightly lengthy. Okay, but you should know how to approach this, right? Okay. So if this is clear, then tell me, I will move ahead. I know you guys got bored when I was solving this. You guys don't like long solutions, right? No worries. So here is another problem for you. This is a simple one. This you should be able to do from all the discussions that we had previously. So you've been told that the velocities of blocks A and B and the pulley P2 are shown in the figure. You have to find the velocity of pulley P1 and the mass C. Okay, so why don't you guys try this? Try this problem quickly. Hurry up and try this. Okay, so okay, I don't know about the mailing bit, but I understand your concern. So what you can do is, okay. The problem is how do I give you my mail ID? Okay. Hmm. Let's see. Yes, even actually, I found some questions which had wrong answers. Even in the Jan session, I'd found such questions. So okay. So let's see. Okay, do that. Mail me. I will reply to you. All right. Okay, so let me give you a mail ID. You can forward it. You can send it there, and they will forward it to me. All right. Just hang on. Because we are not allowed to give our personal ID. So what I'll do is I'll give you someone's official ID. You can mail it to them. They will forward it to me. Okay. So just hang on a bit. I am just asking the mail ID of the person. All right. So here I'm typing the mail ID, so you can send your question here. Sorry. All right. So you mail your problem to this ID. They will forward it to me, and I'll take a look and get back to you. All right. All right. That should help you. So by the way, is there anyone who is trying this problem? Is there anyone who is trying this problem? I don't see anybody trying this problem. All right. So why don't you guys try this problem first? Can I have some answers for this? Guys, give it a try at least. Come on. Give this problem a try. Give me some answers. Don't be so lazy. All right. Yes, D is correct. D is absolutely correct. So good. Well done. Well done. Of course, all you need to do is, use the constraint equation. Oh, that is what you can do first of all. So all right, all right. So let's see. So if you start marking the tensions here, T here, T here, 2T here, and 2T here. All right. So the net work done by tensions is going to be zero, but okay, in ground frame. All right. So first of all, what you need to do is put that work to zero. All right. So the way to do this is that on this the tension would be doing negative work. Why this is going down? The tension is up. On this the tension will do positive work. All right. And let's assume for now. Let's assume for now that this is going up. So I'm assuming this is going up. If it is going down, I will get my answer as negative, not a problem. All right. So now how do I do this? So it is very simple. Let's calculate the work done by tension on all the blocks, and that sum of that should be zero. All right. So what will I get? I'll get minus T into XA. XA I'm assuming down. All right. So plus 10 into XB and plus 2T. Okay, so plus T plus 2T into XC. This should be equal to 0, which would tell me that XC should be equal to XA minus XB over 2. Alright. So now, because of this, VC would be equal to VA minus VB over 2. So VC turns out would be VA was 20, VB was 10. Alright, so 20 minus 10, so that is 10 by 2. So I am getting my answer as 5 meter per second, which is fine, but it's at 5 meter up. What I am getting is 5 meter up. Alright. So 5 meter up, that is the ground frame velocity. I hope they have asked ground frame velocities only. Yes, so it should be 5 meter up, not 5 meter down. All right. Yeah, it should be 5 meter up. Okay, okay, Pawan, no worries, no worries. So now that I have got that, how about the acceleration of the pulley? The acceleration of this pulley obviously would be the average of these. So average of these, what will be the average of these? The average of these is going to be 10, 5, 5 downwards. Okay, so that is weird. Why do I have these? So yes, acceleration of pulley is 5 downwards, which is fine. So these and these may be my correct options. So acceleration of pulley, velocity of pulley would be average of velocity of A plus velocity of B by 2. Okay. So from here, if I'm taking down as negative, so VP1 would be minus 20 plus 10 over 2. So obviously I'm getting velocity of pulley as minus 5, which is 5 downwards. All right. So that is fine. So this or this has to be my answer. How about velocity of C? Why am I getting a different answer for that? Okay, so let's see. Let's see what is happening. Either they haven't given the ground frame velocity, or there is something else. All right, all right. Okay, I need to add this. So that may be one thing. Okay, so it'll be 15 in any case. It'll be 15. Oh, right, 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 right. Right, right, right. Okay, okay, okay. Wait, wait, wait. Okay, so now that I know that this is going down by 5, this is going down by 5. What I need to do here is IIT is less than 500 NSCP. You are great. Okay, thank you. All right, all right, all right. So here is the deal. Here is the deal. So this is going up by 10. So let's assume, okay, why is that not working? Let me just think about that. Why did the virtual work thing not work here? So this would have been 2t, that would have been 2t, okay, okay. So pulleys are supposed to be massless or having mass, is it? Okay, so I think the virtual velocity thing, virtual work is not working because I don't know if the pulleys are massless or not. All right. So the tension might be doing work on the pulleys. All right. If the pulleys were massless, then you should not have gotten these accelerations and these velocities. All right. So that is the issue. So that is why until unless we know that the pulleys are ideal, you cannot apply that because tension will work on the pulleys also. All right, so that is why we will avoid using the virtual work method here. So please remember this. Why? Because we don't know if my pulleys are ideal or not. If any of my pulley has a mass, now I have a problem because I have to take the work of tension on that pulley also. So that might be the case here. However, from the given data, I can still solve this. I can still solve it how? So let us assume with respect to the pulley, with respect to this pulley, which is pulley number 1 or pulley number 2, is it? Pulley number 2. So with respect to P2, so if I come to the reference frame of P2, then then if this is going down by some V, this would be going up by V. So the ground frame velocity of this would be V minus 10 downwards, and that has been given to me as 15. So which means V is 15. All right. So in the reference frame of the pulley, this is going down by 15, which means yes, 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 absolutely, absolutely. Which means that this is going up by 15, and the pulley itself was going up by 10. So the ground frame velocity of C would be 15 plus 10 up, which would be 25 up. Absolutely. Yes, you could have applied that the velocity of pulley would be average of this pulley's velocity and this pulley's velocity. So yes, D is the correct answer. All right. So now remember, yes. So I also did not pay attention, and I was using the virtual work method, which you should not be doing unless you know that your pulleys are idle. Now this situation did not say that the pulleys are idle. That is why that will not work. All right, remember that. Okay. So why don't we try another constraint problem then? So this is another kind of constraint problem that you can get. All right. So here you've been told if block A is moving with an acceleration of 5 meter per second square, the acceleration of B with respect to ground would be. So this is what you have to say. What is the acceleration of B with respect to ground? All right. So let's see you guys try this. Let us see you guys try this. So what will be the answer for this? So just try this quickly. This is an easy one. C. Okay, no. No. Why 5 root 10? Where are you getting 5 root 10 from? Nope. No, Chinmay, no. Okay, think again, think again. Think again. Okay. A. Okay. Is there anyone else who's trying? So let's see some more people try this. All right. Let's see some more people try this, and then I'll tell you the answer. Where is Sukhvinesh? What happened to him? Where has he disappeared suddenly? Okay. So of course, two of you are giving me different answers. So obviously, one of you has to wrong. So why don't you check your calculations once? Just check your calculations quickly. Okay, so Vinesh is trying. So Chinmay says C, Pawan says A. Let's see who got it right. Okay. Just let Sukhvinesh also try. Then I will tell you this very quickly. Okay. All right. Okay. Let us see. Please remember you have been asked the acceleration of B with respect to the ground. So please pay attention to that. Please pay attention to that. Okay. Make sure you are paying attention to that. Okay. Let's see. Can I have the answer quick? Okay. All right. I was just waiting for Sukhvinesh. If Sugunesh doesn't give me an answer soon, then I will. Just let me wait for one more minute. Okay. I don't remember the answer for this, so that is why I'm not sure which one of you is correct. Okay. Okay. So I don't actually remember the answer. So let's just solve this. So you have a block A and then you have a block B. So now the first thing you need to do for these kind of questions, what you do is you always try and go in the reference frame of block A. That is the easiest approach. So if you go into the reference frame of block A, now what do you see? In the reference frame of block A, if this is moving ahead with an acceleration A in this reference frame, in the reference frame of this, the entire wall will start moving ahead with 5 meter per second square. All right. So now what do you see? In the reference frame of A, you will see if the wall comes ahead by X, if the wall comes ahead by X, you will realize there would be X string which will get vacant here, X string which will get vacant here. So this would go down by 2X. All right. I hope you can see that. What happens if the wall shifts here by X? If the wall shifts here by X, then you will realize that X string would get vacant here, X string would get vacant here, all this string would go here, and this would go down by 2X. Are you convinced about that? So in the reference frame of A, in the reference frame of A, no, but that is only in the reference frame of A. In the reference frame of A. You have been asked in the reference frame of the ground. So now I can say that acceleration of B with respect to A is 10 downwards. 10 meter per second square downwards. So what will be the acceleration of B in ground frame, by the way? Alright, so this is it. So acceleration of B in ground frame would be acceleration of B with respect to A vector plus acceleration of A vector. So you have one vector which is down 10, another vector which is here 5. So the resultant, of course, would be this. And this resultant would be A of B, and A of B would be equal to root of 100 plus 25. So that is, okay, root of 25 common, 4 plus 1, 5. So actually the answer is 5 root 5. Okay, so none of the options are correct. Oh, I think there must be a typing mistake here. I think let's just change this to 5, and then that would be the correct answer. In any case, you guys got different answers. Nobody said 5 root 5. So I hope now you understand how to solve such a problem. This is a very tricky problem. Whenever you face such a problem, always go into the reference frame of this block. You go into the reference frame of this block, you will see the wall coming closer. When the wall is coming closer, you can see what is happening to the lengths. All those lengths would go into pushing B down. Alright, so B in the reference frame of A is moving downwards with 10 meter per second square, and A itself is moving 5 ahead. Alright, so the ground frame acceleration of B would be 5 root 5. Alright. Alright. So don't worry, I will have a word with my typist. Alright. Alright, so let's just try one more problem. Let's hope there aren't too many mistakes here. Alright. Don't worry. This happens sometimes. It's okay. So here is another problem for you to try. It says a system starts from rest and A attains a velocity of 5 meter per second after it has moved a distance of 5 meter towards the right, assuming the arrangement to be frictionless everywhere and the pulley and the strings to be light. The value of the constant force F applied on A is. So why don't you guys try this? Just try this. Okay. So I think probably that was just one of a kind or one of a mistake. Usually the guy doesn't go wrong. All right, let's see you guys answer this one. So again, as I said, I'm trying to take up a variety of questions. All right, I am trying to show you different types of questions and how they are solved. Okay, so let's see. So this is yet another kind of question. This is a very different kind of question from what you have seen before. So I wanted to discuss at least 4 or 5 types of questions so that you get an idea about how to approach them, and then you can solve problems on your own. Okay, so follow this. All right. So I hope you have read this question. All right. So find the answer of this. Find the answer of this. Okay. So I hope Pawan you're trying, and Chinmay you are trying, and Sukhvinesh still haven't heard from you. All right, guys. Just write trying in the chat so that I know you guys are trying. C. Okay. Let's see some other answer. Let's see some other answer. Then I'll tell you. I don't want to give hint to other people who might be trying, right? So Chinmay, are you trying this? Or I think Chinmay was also feeling sad that he couldn't get. Okay, so Chinmay is trying. So good, 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 good. Try this, try this. So Pawan, why don't you check your calculations once? Why don't you check your calculations once? That is my hint to you. Okay. All right. So no, this is not correct. This is not correct. 96 is not the correct answer. All right. So Pawan, give it one more try. Let's see. Let's see if you can get that. All right. $75, 100%. Yes. Yes. That is the correct answer. That is the correct answer. Well done, Pawan. So finally you have got it right. Chinmay still seems to be trying. So why don't I go ahead and solve this? Why don't I go ahead and solve this? So again, let's just start marking the tensions here. So let's see. Let's say here the tension is T. Here the tension would be T. Here the tension would be T. And here the tension would be 2T. All right. So now I can write one equations for all our blocks, and then I can write the. Okay, so here I've been told pulleys and strings are ideal. So here I can apply the string constraint by virtual work method. All right. So let's write the equations for the 6 kg block. So for 6 kg block, I can say F minus 2T would be equal to 6A1. Let's call this acceleration A1. All right. So I am saying that this is moving with the acceleration A1. and of course this guy would be moving with acceleration a2. Okay, so for that I can write. So let's assume that this guy is moving up. Yeah, I can do that. So for 2 kg, I can write t minus 20 equals 2a2. So that's my first equation. That's my second equation. Now I have four unknowns, so I need four equations. So which is fine. Which is fine. One I will get from constraint. From constraint, what do I get? What am I getting? T into xb. So if this is going up by xb, and if this is moving side by xa, then what I can say from virtual work is that t times xa minus 2t times uh, t times xb minus 2t times xa would be 0. All right. From string constraint, from string constraint, what do I get? T into x of b minus 2t into x of a equals 0, which means acceleration of b would be equal to 2 times acceleration of a. Alright, so which I'd assumed to be a2 and a1, right? Alright. So let's just stick to that. Let's just stick to x2 and x1. So this is one more equation that I'm getting. So that is my third equation. Now the fourth equation is very, very simple. Fourth equation is about the acceleration, which you can find very easily. It says the system starts from rest and attains a velocity of 5 after having moved a distance of 5 to the right. Alright, so I can use v square minus u square equals to as. So also I know 5 square. So 5 square, where is it? Minus 0 square equals 2 into 5 into a1. Okay, I was calling this a1, right? Yeah. So from here it is very easy. I will get a1 as 2.5. Now which makes a2 as 5 meter per second square. Now it's very, very easy. I can substitute this value here and I will get my t. So t would be equal to 2 into 20 plus 2 into 5, which would be 30. Now if I put this value over here, I should get f. So f minus 60 should be equal to 6 into 5 by 2. So that is it. And f comes out to be 75. So yes, Pawan was right. 75 Newton is the right answer. Okay, let me know if you followed the solution. Let me know quickly if you followed the solution. Alright. So as I said, today is some problem solving day. So that is why it is important for you to keep revising your theory daily. Because I will keep some days to discuss problems. Alright. Because obviously all theory discussion is also of no use if we are not discussing problems. Alright. So now this is a challenge problem. This you can try later. Okay, this you can try later. Consider this to be your homework. Alright. So in the situation shown, the initial acceleration of the wedge of mass, you have to find the initial acceleration of the wedge of mass 5m. Alright, all the pulleys and the strings are ideal and there is no friction anywhere. Alright, so when this system is released from rest, what would be the acceleration of 5m block? So take a screenshot of this. This is the challenge problem. Try it at your home. Alright. So I will discuss this maybe in the next class. Alright. So let me know when you have taken the screenshot. I'll move forward. Just take a screenshot quickly. Just take a quick screenshot of this problem and then we will move forward. Alright. Let me know quickly, guys. Take a screenshot. This is your homework problem which I want you to try later. Okay. Alright. Now, so only thing left in constraints to discuss is a wedge constraint. We'll just quickly go over that, and then we'll look at some other problems, some other kind of problems that you have in Newton's laws, and then that's it. We will wrap up the session. So, what is a wedge constraint? So, any object moving in contact with the wedge is restricted in its motion again, because whenever there is a contact, the motion gets restricted. So, what is the restriction for any object's motion? If the wedge was stationary, if the wedge was stationary, then any object could have just moved along the incline, right? So what happens if the wedge can also move? If the wedge can also move, then what you do to find the equation of wedge constraint is you go into the reference frame of the wedge. Now, how do you see? When you move to the reference frame of the wedge, you should see the wedge stationary. If the wedge is stationary now, the block in contact with the wedge should only be able to move along the incline. Alright, so remember this. So when the motion of such an object is observed from the reference frame of wedge, it can only be along the incline, and there can be no acceleration or velocity perpendicular to the incline in this reference frame. So that is the trick. Now this forms the basis of obtaining the wedge constraint equation. This is how you do it. So let's just try an example here. So if I had to find the accelerations of both these masses, how do I do that? So first I would have made FBDs of the masses. All right. So let's try the FBDs. So one, it would be feeling mg. Another, it would feel an n. Let's call this n1. All right, this is the n that it feels from the wedge. All right. So this, obviously, you will know that this would be 90 minus theta. All right, why? Because this is theta. So your n1 can be divided into two components. So this would be n1 cos theta, and this would be n1 sin theta. Now this rod is restricted to move only in the vertical direction, and this wedge will only move in the horizontal direction. Alright, so if I can write the motion equation for this, let us assume that this is going down with a1 and this is going on this side with a2. So for small m, what can I say? I can say that mg minus n1 cos theta would be equal to ma1. So that is my equation number one. Similarly, if I talk about capital M, the wedge would feel n1 sin theta here, and it will feel n1 cos theta like this. Alright, so this is the reaction pairs of these components only. I am directly applying reactions of components only. Alright, then it would be feeling some mg, and of course it would feel some ground n. So in this direction, the only force causing the acceleration is n1 sin theta. So now for capital M, I can write n1 sin theta would be equal to capital M A2. So this is my equation number 2. Now what I need to do is I need to obtain the constraint equation. So for constraint equation, what do we do? See, let's take a look at the accelerations from the ground frame first. So here is your wedge. Here is your rod. So from the ground frame, this was moving on the side with A2. So if I come to the reference frame of the wedge, now what do I see? I will see from the reference frame of the wedge, this guy will have an acceleration A2 in this side and again an A1 in this side. So the resultant would be somewhere here, and I know that the resultant should be making an angle of theta with the horizontal. Alright, why? Because the resultant acceleration has to be along this direction. This has to be the direction of a resultant in the reference frame of wedge. There is no other option. That is how I get my constraint equation. So what can I say from here? So let's draw A2, let's draw A1, and now I have a resultant. And this I know angle is theta. So from this triangle, what I can say is that tan theta equals A1 over A2. Alright. From wedge constraint, you will have that tan theta equals a1 over a2, or I can say a2, or a1 is a2 tan theta. Okay, so this is my wedge constraint equation. This is equation number 3. Now that I have 3 equations, 3 unknowns, I can solve all of them and find all my unknowns. All right. So what were the unknowns? N1 was not known, A1 was not known, A2 was not known. So I had 3 unknowns, N1, A1, A2. Now I have 3 equations. Now I'll be able to solve this. So I'm not going to solve this. I just wanted to show you how to get the wedge constraint equation. So what we did was we assumed that in ground frame the rod was moving down with A, the wedge was moving sideways with A2. Now I came into the reference frame of the wedge. I looked at the rod. Now rod has 2 accelerations. Okay, one this side with A2, one down with A1. The resultant is in this direction. Now resultant in the reference frame of the wedge has to be along the incline. I use this fact and I got a relation between A1 and A2. Now this is what my wedge constraint equation is. So remember this example, and this is how you will always calculate your wedge constraints. Okay. So this is the wedge constraint equation. This is a tough concept. It needs a lot of practice. All right, this is, trust me, not easy. You will not see this uh, even in mains. This is an advanced level concept. Okay, so you won't see this question, this type of question easily. Wedge constraint equations obviously are very very difficult to visualize. So because you see there is vector addition happening, so yeah, a lot of people find it difficult, but you should be fine with it. How many days should I give to basics? Okay. So go through the lectures, practice, and as soon as you start feeling comfortable, that should be it. Now let's go back to our problem solving strategy. This was my problem solving strategy. Select a system, study the system. By studying the system, you identify all the forces acting on it. So all the external forces, rather, let me add external. Alright, then draw a free body diagram, resolve all the forces along the coordinate axis. Now write all the F equals ma equations for all the directions. Identify the constraints. Now we know how to identify the constraints. I hope you guys have figured it out. Generally, you will have string constraints or wedge constraints. You know now how to calculate both. And finally, solve all the equations to find your unknowns. Alright, so let's try some more problems. So this is an example of your wedge constraint. So let's see. A sphere of radius r is in contact with a wedge. The point of contact is r by 5 above the ground as shown. If the wedge is moving with a speed of 20 meter per second at the instant shown, what is this speed of the sphere at this instant? Okay, so what is the velocity of the sphere at this instant? That is what you have to find. More than enough, more than enough. For Newton's laws, right? For Newton's laws, I think 3 weeks is more than enough. Alright, so try this problem, guys. Why don't you try this? Let's see. Let's try this quickly. Alright, there's a huge variety of problems that is possible with Newton's law, so you will need a lot of practice. Alright, so that is why I am going through, a few kind of problems myself. Alright, so that I can show you as many as possible. Of course, I can't show you all. I can't solve all the problems here possibly, but at least I wanted to solve at least 6-7 kind of problems, so that you get a hang of how to approach the problems. All right, and you can go ahead with your problem solving. Okay, Let's see if I have any answer. Confusing. Okay. Think about it. Think about it. Yes, the problems are going to be hard also, Chinmay. See, as I told you, I am discussing everything from mains level to advanced level also. I started with very basic things. I discussed the pulley problem also. See, so that is a board level problem. This problem that I discussed was a board level problem. Then I discussed some more complicated problems. So like this. So that would be a mains level problem. And now you are here. These are the advanced level problems. So we need to discuss it all. Don't worry. See, if you are aiming to crack advanced, you need to try these tough problems also. But don't worry. When you start understanding the concept, when you start understanding the idea, it will be easy. It will be easy. What is the trick that I told you? What is the trick? It might be 10. Okay. Not really. Not really. Okay, 10 is not the correct answer. So what was the trick that I told you? That in the reference frame of the wedge, the body in contact should appear to move along the incline, right? So let's give it a try. So if I move to the reference frame of the wedge, 20. No, 20 is not correct, Shruti. 20 is not correct. So let's see how to solve this. So if I move to the reference frame of the wedge, now what should I see? So the wedge obviously will appear stationary. This guy already had a velocity v upward, and this guy will have now a velocity of 20 here. So the net velocity would be a vector sum of these two, and that should be up the incline, right? So all I need to do is find the angle of the incline. If I can do that, then I should be good. How do I find the angle of the incline? So I know the resultant of these two. The resultant of these two, that is 20 and v, should be this v resultant. And that should be along theta. If this is theta, then this should be theta. Alright, I hope you guys are following this logic. What I'm trying to do. Alright. What I'm trying to do is I'm trying to look at the sphere from the reference frame of the wedge. The wedge had a velocity towards left of 20. So in the reference frame of the wedge, the sphere will have a rightward velocity of 20. The sphere already had its own velocity, which was up. So the velocity of the sphere in the reference frame of the wedge would be a vector sum of these two. And that has to be along the incline. That is what I told you. That is how you calculate your wedge constraints. Now, the only trick is now to figure out what theta is. So from wedge constraint, what I can say already from here is that tan theta should be equal to v over 20. So tan theta should be equal to v over 20. That is my wedge constraint. This is my wedge constraint equation. I hope that is clear to you. Alright, how I got this wedge constraint equation. I told you the trick for getting wedge constraint equations is that whatever is touching a wedge, you go to the reference frame of the wedge, you look at that thing. Now that thing should have a velocity or an acceleration only along the incline. Alright, so that is the trick that I use. I looked at the resultant velocity in the reference frame of this guy, and I assume that this has to be along the incline, so it has to make an angle of theta upwards with the horizontal. Now all I need to do is figure out what theta is, so that is again easy. So now I know that this is r. Okay, so here if I drop a perpendicular, this I know is r over 5. Alright, so now all I need to do is, if this is theta, then I know this will also be theta. Alright, I hope you can see that. I hope everyone can see that. You take a look at this triangle. If this is theta, this would be 90 minus theta, and hence this would be theta again. Why? This is perpendicular. Alright, so if this is theta, then this is also theta. Alright, so now you should have this easily. What about this side? If this is O, this side is R. What about this? This was R by 5, so this would be 4R over 5. Alright, so what is this side? Now if this side is some x, then now I can apply Pythagoras theorem, right, and find x. So I can say, now let's figure out what tan theta is. Alright, so I can say x square. Okay, I can say x square plus 4 by 5 r whole square should be equal to capital R square. Alright, so let's see what that gives me. So x should be equal to r times, okay, so that'll be 25, 16 over 25, 3 over 5. Alright, I hope you guys can see this. Okay, so let me just quickly do this. X square equals r square 1 minus 16 over 25. So that'll give me x square equals 9 over 25 r square, and that is how I am getting this. Alright, now once I have x, once I have this, now from this triangle, see what tan theta is. Tan theta would be 3 by 4. Alright, I hope everyone can see that. Alright, once I have found x, therefore tan theta is nothing but perpendicular, which was 3r over 5, over base, which was 4r over 5. So this comes out to be 3 over 4. Now all I need to do is substitute this value here. So I know V would be equal to 20 tan theta. So V equals 20 into 3 over 4. So V comes out to be 15 meter per second. That is my answer. Hello, 0 Kelvin. What is partially opening? So my answer is option number B. Okay. I hope all you guys followed this. This is a tricky problem, but trust me, it's not that hard. It's not that hard. You have to apply some geometry and a string constraint. That is it. Alright, Chinmay, are you okay with this solution? Just go through this solution. There is nothing very tough about it. Okay. All the concepts involved are one, wedge constraint, another Pythagoras theorem. That's it. Alright, so the solution is not that tough, trust me. So okay, what is opening partially from 21st September? Schools. Are you talking about schools? All right. So if you guys followed this, then should I move forward? Should we move forward then? Let me know if we can move forward. This is the question. This we got the answer as 15. Yes, you do. You do that. You do that, Chinmay. Till then, let's try and solve some police problems with springs. Okay. So in this problem, you've been told. Okay, so this is another kind of problem which we haven't discussed so far. That is why I wanted to discuss this kind of problems also. So in this problem, you've been told two blocks A and B of masses m and 2m respectively. So this has a mass of m. This has a mass of 2m. All right, are hanging from a ceiling by means of a light spring and a light string, as shown. You have to find the elongation of the spring if its spring constant is k. Yeah, why not? Why not, Jay? Why not? Do it. Do you have interest in pursuing it though? Are you interested in pursuing it? The second part, you have to find the acceleration of the blocks immediately after the string between the two blocks is suddenly cut. So if what happens if I cut this suddenly? What will be the two accelerations then? So this is another thing that we hadn't discussed so far. That is why I wanted to discuss this problem. So Jayakash, completely depends on you. Okay, if you think you can find the time, because KVPY study would be slightly, you'll have to study slightly extra. Okay, from the kind of questions that they ask are slightly difficult, even for even from advanced level. They might be slightly difficult. Okay, and they are quite tricky. So you will have to put in extra time. If you think you can do that, then you should go for it. Right? If you don't think you can, then maybe just focus on your JEE. All right. So completely up to you, depending on how good you think you're prepared and how much time you think you can put in. All right. So G by 2 and G are fine. No, 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 no. Okay. Yes, yes, yes. Upward, downward. You have to tell me the directions. You have to tell me the directions also. Upward or downward. And no, I don't think so. Yes, Chinmay. Yes, I can imagine. Just go through all the videos, try and understand everything, and then practice some. Okay, no problem. Biology, yes, exactly. That is another thing. So you are in class 11th right now. So why don't you give it in class 12th? Class 12th, you won't have to take biology. Okay. So first of all, see, the reason why I wanted to discuss this problem was that I had told you earlier also that the spring force cannot change instantaneously. So earlier, before it is cut, now what you can do is both A and B are at rest. So since they are at rest, that means their acceleration is zero. I can take this as one system. So if I take this as one system, then so I have a 3m block which would feel a 3mg force downward, 3mg force downward, and it will feel a spring force upward. So for equilibrium, I know the spring force would be equal to 3mg, and spring force should be equal to k times x, where x is the extension in this spring. So from here, x would be 3mg over k. So that is the answer for your part A. So that is very, very simple. Oh, yes, I do. Yes, I do. Okay, you are a PCMB student. Then you should, Akash. I thought you were an engineering student. Now is the problem. When this acceleration, when this string is suddenly cut. When this string is suddenly cut, what happens? Let's see. When you cut this suddenly, the tension force would disappear suddenly, but the spring force never changes instantaneously. So just after cutting the spring, let's see what the FBDs look like. So that is why I wanted to discuss this problem. So just after cutting the spring, now please remember, spring force never changes its value instantaneously. So what do you see happening to A? So A is feeling a downward force of mg. It is feeling an upward force of spring force, which will still be equal to 3mg. All right. So okay, your answer was wrong. And what about B? What about B? B would be feeling a force downward of 2mg. That's the only force, because the tension immediately disappears unless a string is tight. So when you cut the string, it won't remain tight. So the tension would immediately become zero. Okay, so what is my qualification? Okay, I will tell you about that. So how about the acceleration of A now? First, let's calculate the acceleration of A. Acceleration of A would be 2mg over m, which is g, and it would be upward. Oh, 2g. And similarly, acceleration of B would be, that would be 2mg over 2m, which would be g. Again, this would be downward. So, okay, both your answers were wrong. Oh, good, Phoenixian. Alright, so these are your answers. Acceleration of A would be 2g upwards. Acceleration of B would be g downwards. Now you need to remember this fact. that the force of spring never changes instantly. Remember this. Spring force never changes instantly. Alright. If you remember that, all these problems would be fine. So again, here is another problem which you can take as homework. Okay, take a screenshot because my time is over now. I have another session in some time. So take a screenshot. This is your homework. Alright. Now you should be fine. Just calculate everything before the string or spring is cut. Now, okay, please remember one thing. What happens if the spring is cut? What happens if the spring is cut? What do you think happens then? What happens if I cut the spring? What do you think happens if I cut the spring? Then what happens? Yes, Phoenixian. Ask me, ask away. Ask away, please. Delta means change. Delta means change. Delta is something that we use for change. Alright. So this is the symbol for delta. It implies change. Alright. So delta x means change in x. Similarly, delta y would mean change in y and so on. Delta v would mean change in velocity. Delta a would mean change in acceleration and so on. Gravity is positive or negative? Okay. So, gravity is neither positive nor negative. The force of gravity is positive or negative. Force is a vector. Force is a vector. It depends on which direction you're taking as positive. So we take it to be negative because it acts downward, and downward we take directions as negative. By the way, please remember this. If the spring is cut, nothing happens. Nothing happens. Because you can consider this to be two springs. Two springs, both were applying kx forces. So even if you cut that, both the spring forces do not change immediately. So if you cut the spring, then immediately after cutting the spring, both would have been at rest. Please remember this. Alright. Okay. So I hope you got that. If I had cut the spring instead of the string, the acceleration of both would have been 0. Alright, here it is. Okay, okay. Alright, just take a click. So remember that is very, very important. Okay. If you have clicked this, then I can move forward. So I had this ultimate challenge problem also, which you can try. Okay, okay, okay. I will wait. Alright. So try this problem. Let me know when you're done. Let me know when you're done, and I will give the ultimate challenge problem also. Alright. Got it. Okay. Great. Now this is the final ultimate problem of the topic. In fact, this is one of my favorite problems of the Newton's laws. Alright. So try this. Try this as well. Okay. And try it on your own. Try it on your own. Don't Google it. Don't doubtnut it. Okay. I hate when that I think makes students lazy. You guys don't want to try problems anymore. You just want to Google answers. You just want to go to Doubtnet and find the answers. All right, which I really hate. I would want you guys to try 5 times, try 10 times, and if you can't understand, then also go to your teacher and understand from your teacher. All right. Oh, I don't remember. I don't remember. There were 2 parts in any case. I am feeling electrostatic stuff from my college lectures. All right, Papi, have you seen my lectures? Yes, but then it that should be the last option. See, that option should be taken only when your teacher is not available. All right, and you shouldn't give up very easily. What happens because of Google and internet is that you guys start giving up very easily. You don't put in a lot of hard work. I don't remember. Are you talking about this? So have you taken a screenshot of this? So try watching those. Maybe that will simplify things for you. All right. So okay, try and catch a screenshot of this. And till that time, you wanted to know about me. So let me tell you about myself. This is my qualification. Okay. So I have studied mechanical engineering from IIT Delhi. All right. I have been teaching physics for almost 8 years. Physics for IIT JEE. And I've been associated with some of the topmost institutes in the JEE industry. Okay. So I have taught offline before this. This is the first time I'm teaching online. I myself was All India rank 447 and All India rank 192 in the two stages of JEE. Yes, like now you have mains and advance. Now you have mains and then advance. Back when I took, then it was called screening and mains. That is what it was called back then. No, 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 no. All right. This was objective and this used to be subjective. So I took my JEE when it was subjective. All right. That is what I meant. This used to be stage one. This used to be stage two of the JEE exam. How can you cover above 40 marks with limited chapters in physics? Okay. I'm not sure what you're trying to say. I also qualified NTSC Stage 2 and I was in the top 1% in the NSEP, which is the National Standard Exam for Physics or the Physics Olympiad. All right. So I hope that much information about myself is enough. All right. So let's go back to this. All right. So that is it. I would like to wrap it up today. All right. So before I leave, let me remind you how you should be getting your Unacademy subscriptions. Go to Plus, select your goal as IIT JEE. Many. I have my students who are in their jobs now. I got a call recently from a student who got placed with JP Morgan. All right, Morgan Bank. Okay, that's a very prestigious job, by the way. So that is how you do it. You go to the plus section, you select your goal as IIT and you click on that get subscription button. All right. Now, please remember the prices are going to get hiked from tomorrow. So hurry up in getting your subscriptions. Get them at these prices before tomorrow. All right. Because after tomorrow, the prices will become like this. They will increase a lot. All right. So hurry up. Don't waste your money. Save up on your money. Get your subscriptions now. Use this code. This will make your prices less from this. This is the actual cost. Use this code, get a 10% off. All right. You give personal teaching. No, I'm not giving any personal teaching right now. I was earlier teaching in offline institutes and one of the biggest names in India in the coaching industry. All right. And now I am offline. This is the first time I'm teaching offline because of all the coronavirus. And I think it's best that you should also stay at home and maybe study online only from me if you want. But don't forget to use RD Live when getting your subscriptions. No, I don't think I'll have the time for that. Okay. No. So only one day to go. Get your subscriptions fast before the prices get hiked. Okay. So if you like today's video, if you like the kind of problems that we discussed, then press the like button, share this video with your friends. Again, as I keep saying, that for those of you who can't afford this subscription, also the Unacademy is providing you free content on YouTube, and this is quality content that more and more students should access and benefit from. All right. Good evening, DK Prodigy. Okay, you came late. I am wrapping up my session. Don't forget to press the bell icon, and the PDF of all the slides used in today's lecture would be available for download very, very soon. Okay, first of all, no, I don't teach on a personal basis. All right, I hardly have any time. Trust me. You can join the Unacademy Plus, and you can join my courses there. Don't worry, I will give you full attention. All right. So those of you following us on the J English channel can connect with us on the Telegram app using this link. All right, and this is where I leave you for today. I will see you next day after tomorrow. We will carry forward our discussion from here on. So on Friday we'll be talking about non-inertial reference frames and pseudo forces. All right. So before I go, let me remind you one last time: use RD Live to get your Unacademy subscriptions. Get them today. Get them before the prices get hiked. Use this code and get 10% off. All right. So what can you do? You can get the subscription. You can enroll in my courses. All right. The subscriptions are very cheap in any case. All right. Don't worry. You will get my personal guidance there. Okay. So that is it for me. All right, for today, I will see you next on Friday. Till then, keep studying, keep practicing. All right, take care.